Hi, this is a battery pack that I made in this waterproof case, but when I end up finish mounting it, it won't be waterproof because there'll be holes in the top up here so the power cables can come out, and I have a voltage meter I'm going to put in there and possibly a charge controller, but I use a constant voltage charger right now to charge this, so that is my charge controller. But the reason I made this for is because I like to make some trips with my Chevy Bolt, and I wanted to have the infrastructure up here in North Dakota is terrible. The route that I want to go on, which is a little over 1,300 miles, is through Highway 94, Interstate 94, down to Billings, and you get on 990, then you go 191 south through Yellowstone National Park, and on your way down to Highway 2, I believe it is, or it's 20, Highway 20, going into Idaho Falls, and that is the first DC quick charger, and that is over 1,100 miles away from our house. But in between there, they have level 2 chargers. And though I wanted to make this, because I'm going to be doing that reverse trip from Salt Lake City back here, which I will video, and I wanted to have 10 extra miles of range. So I built this pack with these C-Max, Ford C-Max cells. There's 7 in parallel and 11 in series. So the pack fully charged is 29.4 volts. And one thing you do when you turn on the inverter is you have this little tester here. This tells you, is it correctly grounded? And the one light indicates it is not. What I've done is I made this little thing right here. On any electrical circuit you plug into in a household, the correct way to wire that is, this will be the hot right here, this bigger one will be the neutral, and this one will be the ground. So what I've done is I've made this little device, neutral over here, hot over here, ground here. I put a wire between the neutral and the ground, and so it will fool this inverter or a generator, because I understand generators are the same way. And if I plug that in, bingo, it shows that I have a ground fault, or I don't have a ground fault. So with this in here, I can charge my car, and I've already done so, and I've added 2% to it. But being it's so cold out right now, -2, and it's cold in the garage because it's not heated, 120 volts at this particular time of the year, most of it would go right to heating the battery pack. So when I take this, it'll be a normal battery temperatures of between 50 and 70 degrees when I go to make that trip. So we pull this thing out, and now we have a usable inverter. And I have tried it. I was going to do it today, but it is -2 right now, and it is cold out there. So, and all the power would be going to heating the batteries, because 120 volts, as you well know, does not add very much power to a 60 kilowatt hour car. So what we're going to do is this. For my test, I'm going to measure the voltage of this battery pack, and it should be right around 29.5 volts, which means I'm 1/10 over maximum charge, which you don't really want to charge these batteries over 4.2. They'll start going. But the constant volt charger I use only puts out 3 amps for 77 cells. That's not very much power. So anyway, what I'm going to do is plug in this, and this is a kilowatt meter, and I have it reset to 0, and I'm going to measure how many kilowatts I can take off in the next hour or so, being that it's fully charged. It's at 119 volts. Can you see that? Yeah, 120. So I'm going to plug this in, and this is for a space heater, and what I want to see, by spec, this is supposed to put out 1.77 kilowatt hours bringing it down to 2.5 volts. Well, you don't really want to go down this, and this inverter will only go down to 20 volts, which it brings it down to about 2.72 volts, which is lower than I want to do, but I'm going to take it down to 20 volts. The inverter will shut off, and I'm going to see how many kilowatts, if the specs on these batteries are correct, at 23.1 watts per cell. So here we go. I'm going to turn this up so we can see how many watts it's taking. 1406 watts. It's almost a full capacity of this, even though it will surge to 3000 for probably 10 milliseconds. But it's a 1500 watt inverter. So here we go. We'll see how long it lasts. Right now it's 1520. It's only 3 minutes, but we use 0.08 kilowatt hour. And the battery's down to 28.39 volts. And 119.6 volts. And remember, this is a pure sine wave inverter. 11.63 amps. 1392 watts. It's been 10 minutes now, and the wattage is still 1405. Voltage has dropped down 1.5 volts. 27.48 right now, and it's dropping. Now what normally happens is you start losing voltage, your amperage is going to go up. Your wattage and amperage. Let's see what the amperage is. Still 119.6 volts. Amps is at 11.66. The fans have not come on the inverter, but you can feel it. It's warm. It's almost putting out maximum power. It's been 22 minutes. We're using 11.48 amps. We're down to 26.21 volts. The inverter still warm, but the fan has come on several times, so it's doing its job. Oh, let's see, 1351, 52, 51 watts right now. Still going fine. I do have the space heater set at 64 degrees, so it's coming on and off, so the amperage has varied, the wattage has varied a little bit. Continue watching it. We're coming up on 30 minutes. We're at 25.63 volts, and we used 0.66 of a kilowatt hour so far. We're at 40 minutes and still 1350 watts, 11.45 amps. .85 kilowatt hours at this point. We're at 24.98 volts. Now we're at 46 minutes and we used 1 kilowatt so far. And we are still 117.7 volts, 11.47 amps, 1347 watts. We're coming down to 24 volts. We're at 1361 watts. Hundred 118.1 volts, 11.5 amps. And the time is 51 minutes. We're approaching 23 volts right now, still putting out 11.5 amps, and we're at 54 minutes. So as it drops in voltage, it goes faster and faster, depleting the batteries. Let's see, and we are at 1.17 kilowatt hours so far. We just passed 22 volts, 55 minutes. Still going down fast. Just past 21 volts. And it's going down super fast. And we've used 1.21 kilowatt hours. And it should cut off at 20 volts, the inverter. We'll see. It's coming up real fast. There we go. It'll bounce back some, but as it looked like we used 1.22 kilowatt hours. The specs say it's 1.77 kilowatt hours for these batteries. Now I don't know how many cycles they've been through or anything like that as far as these go, how many cycles they've been through. What I'm going to do, now that I have these statistics, I'm putting together these packs right here, and these are in 7 by 15. So 15 in parallel, 7 in series. And I'm going to put 5 of these in a smaller pack than this. As soon as I get it done, you get cut a lot of these. I spot welded all the negatives together, and I'm going to solder the fuses on each of these. So I will compare these, and so there'll be 5 of these in series, so that'll be a little over 500 cells, and we're going to see which puts out more energy doing the same test. Thank you for joining me.